Answers weren't repeated. Once, going twice. All right, opening it up for review of any problems in problem set 18 from the homework. Yep.
So one, I don't really get how. Okay, so like this is from like let's start problem 20.
Problem 20, okay.
And it's just from like the second like term, I guess, or the second part where it's 3 minus -2, right?
Yep.
How is it that -2 is going to become positive and it's going to be adding? I don't get that.
Okay, so 3 minus -2. You want to know about this? 3 minus -2.
Yeah.
This thing here. All right, remember what these different things mean in terms of the number line. So we've got, 0, 1, 2, 3. -1, -2, -3. 3 means this number here, positive 3. It's to the right of the 0. Would somebody get me a, go ask Mrs. Streeter for another prime erase marker? This one's working out. -2 means this guy over here. It means the opposite of 2. This would be 2 positive 2. -2 is on the other side. When we add numbers together, if we're adding positive numbers, we're taking these distances and we're combining them. So 3 plus 2, we take 3, and then 2, this distance here, we're combining those distances together. We end up at 5. When it's a negative number, the distance goes the other way. So 3 plus -2, for example, would be 3 plus -2 would take us back. When you subtract, subtraction really means adding the opposite. Because if we do 3 minus 2, that's the same as 3 plus -2. 3 minus 2, minus switches the direction that we're going in. 3 minus 2, okay, we need to go this distance, the distance from 0 to 2. We're starting at 3, and we need to go that distance backwards because we're subtracting. So subtraction flips the direction that we're going in, just like the negative sign flips the side of 0 that we're on. So when we have 3 minus -2, so we've got 3, and we want to subtract. So subtraction, normally we go this way, back from the number, but we're subtracting a negative, so it's going to flip the direction again, so we're actually going to go this way, which is why it's going to become 3 plus +2. Thank you very much. Next, things from pages 80 and 81, problem set 18. Constance, do you want to review?
Oh.
Yes.
Awesome. So 14, right?
Mm-hmm.
So the whole thing would be written out as -3, negative parentheses, -3 parentheses, 6 plus parentheses, or 6 minus parentheses, -3 parentheses, or bracket,
Yeah. Yeah, we should like switch between different signs. Yes, that's how you would write it out.
So, when you do the parentheses, right?
Mhm.
When you do everything there,
Yep.
and now -3 is multiplied by 9, right? Or
Well, be careful. So let's do the parentheses first. So what happens inside these parentheses? 6 minus -3.
would be 6 plus positive
Right, which will give us
9.
9. Yeah, 6 minus -3 is 6 plus 3.
So,
And then what happens over here? Please be on time. You have problem set 18? Do you have problem set 18?
so
Take that a second, check it, and go over some of the problems.
-3 would be -3 would be +3,
Yes?
and then when you multiply it would be what 27?
Yeah, 27.
Positive 27?
Yes.
Oh, okay. Alright. That's
Yeah,
why
you can think of this also, remember the negative sign means times -1. You can think of it as -1 times -3 times 9. You can multiply those three together in any order, you'll still get positive 27. Because there are two negative signs, and when there are 0, 2, 4, 6, 8, whatever negative signs, they'll cancel each other out. Alright, other things from this problem set you want to go over, or concepts that you want to go over. Let's make sure we don't fall behind. Remember, the way this book works, the way that math in general works, it's just the nature of the subject, is that we're always building on things that we learned before. So we want to make sure that we're not forgetting lessons 1 through 12 when we're getting ready for the test that's going to cover up through 16, which the next test will be. The next test, by the way, so we're going to do 19 today. So it won't be tomorrow. Monday we have no school. I don't want to give it on Tuesday. Wednesday you guys have the PSAT, so there are no classes. So the next test, it looks like will be on Thursday. So a week from today. Yeah, you guys take the PSAT.
Oh.
You. Yes. 9th grade, yes. Wednesday.
Why?
What? Yes, it's just the morning for you guys. You take the PSAT, you go home.
Yeah.
That's like
That's on Friday?
Yeah, basically, that's on Wednesday.
Oh, Wednesday?
So you got Monday off, and then Tuesday we got class, and then Wednesday you guys just have the morning of the PSAT.
So wait, I have a question. I was reading something about the PSATs, right?
Uh-huh.
They stay on your year's record, and then as soon as the school year ends, it gets removed, right?
I don't know that they go on any records, any Avalon records.
Yeah, I'm pretty sure practice. Like it's only practice.
9th and 10th grade, the PSAT doesn't really count for anything. What you can do is depending on, what will happen is depending on the information that you put on there, what things you're interested in and your score and these sorts of things, is that you will start getting contacted by colleges that think that they want you.
No, I do.
Hmm?
I don't think that they do.
Well, they think they might want you. I mean, there's still the application process for that. But so you'll probably start getting a lot of mail. But so when you are filling out the information about yourself, like things that you're interested in, that's going to affect what schools contact you, like send you mail, advertisements, emails, and that kind of stuff. So think about, you guys don't need to worry about it yet. All right.
Do we need to go to college, like actually?
No.
Okay.
That's the short version of the speech. All right.
For real.
Continuing. Obviously, that's not supposed to replace any advice or instruction that your parents are giving you. All right. Other things from problem set 18.
No, yes. Yes. I would like to go over number 15.
Number 15. All right. We've got, yes, these type of ones often cause issues. All right, 15. We've had, let's make sure we got that correctly. Negative x minus parenthesis negative a, close parenthesis, open parenthesis, a minus x. And what do they say? A is equal to?
A is equal to -4.
A is 4, positive 4. And x is negative 2. Make sure you copy those down right. X is negative 2, a is 4, then x minus negative a. Okay. This sort of thing is a really good instance of, it takes 3 seconds to check that you wrote it down correctly, and can fix some easy mistakes. All right, so when we plug in the values for our variables a and x, how are we going to write this? Someone walk me through, tell me one symbol at a time what I'm going to write. Let's not simplify anything yet. Negative parenthesis, negative 2. What am I going to write next?
Oh, minus.
Minus?
Negative 4.
Minus negative 4.
And then 4 minus 2.
Yeah, 4 minus negative 2. All right, now, if you're really comfortable with these things, in a circumstance like this first one where it's got the negative sign there, you could just skip to writing 2 if you're really comfortable with these. But when I'm going to do them, I'm always going to go every single step. So first I'm writing it out the way they gave it to me, then I'm just plugging in the values of the variables. Now what am I going to do next, my order of operations?
Parentheses.
Parentheses, what do I do inside the parentheses?
4 plus 2.
What do I get?
6.
6. Okay, so this becomes 6. All right, so now I did parentheses. Notice I didn't change anything else. Now what I'm going to do?
Or not 6.
Not multiplication. Two is gonna be positive. Negative 2 is gonna be positive 2. Negative 4 is gonna be positive 4.
Okay, so, but what else can I do?
4 times 6.
Yeah, 4 times 6. Remember the negative sign, we can think of it as meaning times negative 1. So yes, negative 2 when we do multiplication becomes 2. Minus negative 4 times 6, we can think of minus as plus negative. So negative 4 times 6. Negative 1 times negative 4 gives me positive 4. Times 6 gives me 24. And then once I do my last step, what am I going to get?
26.
26, yes. I go one step at a time. One step at a time.
Why is Monday?
Why is what?
Monday off.
Columbus Day.
I was like,
None of that. Hold on. All right.
huh?
That's
All right.
Indigenous people.
That's the drug.
Yeah.
All right. What else?
Number 23.
23. All right. 23. Negative 2. Did I copy that down correctly?
Where? Yes.
Try again. Did I copy this down correctly?
Wait. You forgot a negative
Ah, yes. Where did I forget a negative sign? Forget.
3.
Yeah, it should be negative 3 here. All right, it's an easy thing to forget.
Oh.
This time I actually did it on purpose. But all right. So what are we going to do first here?
In the parentheses on the top.
Okay, we're going to deal with the top first. What are we going to do with those parentheses?
It's gonna be 4.
It's going to become 4. All right. What's going to happen next on top?
It's negative 8.
It'll become negative 8 multiplication. All right. What about on the bottom? What do we do?
Positive 6.
Positive 6. All right, that stays. What can we do with negative 8 over 6?
Divide by 2.
We can divide both by 2. What do we get?
Negative 4 over 3.
Negative 4 over 3. We could also write that as
1 and 1/3.
negative 1 1/3. Yes, as an improper fraction or as a mixed number.
Yeah, that's fine.
Either one of those is fine for my class. Improper fraction or mixed number. All right, maybe 1 or 2 more.
Number 24.
24. All right, similar kind of problem.
Fractionized problem.
Fractionize. All right, we've got negative 2 on top. Minus 2 times 3 plus 10 over 3 minus negative 2 times negative 3. All right, what do we do? What do we want to do, top or bottom first?
Top.
Top. All right, what do we do first on top?
Multiplication.
Okay. What do we get?
3 times negative 2.
Okay, gives us
Negative 6.
negative 6. So we got negative 2, what? What am I going to write here?
Oh, negative 2 plus negative 6 plus 10.
Yeah. All right, what happens next on top?
Addition.
Yep. We end up with?
Negative 8 plus 10.
Yep, which is?
2.
2. All right. What happens on bottom? First?
Let me see. Multiplication.
Multiplication.
So it's 3 times 2 times negative 3.
What things are we multiplying together here?
Negative 2 times negative 1 times negative 3.
Right, negative 2, negative 3, and negative 1, yes. And so what do we end up with?
Negative 6
Yes, so 3 plus negative 6.
times 3. Oh, it's plus 3.
Yes. Remember, when we change the subtraction, it's going to become addition of a negative. So 3 plus negative 6 gives us
-3.
-3. Now, usually with fractions, to simplify a fraction where one's a negative, we're going to change the negative sign. Either write the negative sign outside of it or write it on the top. I prefer to write it on the top personally. I think that's more useful. So I would write -2/3. You could also put the negative sign to the left of the whole fraction. You could also leave it on the bottom. But I recommend this. Remember, with fractions, because it's division, if one of them is negative, then the whole thing is negative. So it doesn't matter whether it's the first one or the top one or the bottom, the divisor or the dividend. Divisor or the dividend. The numerator or the denominator. All right, one more. Then we got to talk about exponents. 25. Okay, we're finding perimeter. How do we find the perimeter of that?
6 plus 6 plus 24.
Let's see what we have here. What's our unit?
Yards.
Yards. All right, so we're going to have, as you said, 6 plus 6. The other 6 is the top of this rectangle. Where'd you get 24 from?
The other side,
How do you know that that's 24?
because it's the thing right there. The circle. It's the full length of the circle.
Right, it's the diameter of this semicircle. We know the radius is 12, so all the way across the diameter must be 24.
Yeah.
All right, and then we still got this part, this curved part. How are we gonna figure that out?
Yeah. I'm doing our formula, which is 2 times that number 2 pi r.
Is 2 pi r, but do we have a whole circle here?
No.
So we want half the circumference, so we're gonna divide it by 2.
Yes.
All right, so we need to do what?
2 times the radius, which is 24,
Mm-hmm.
divided by 2,
Mm-hmm.
which is 12,
Mm-hmm.
which is,
Don't forget about this guy.
pi.
Yeah, 12 pi. Yeah, remember 2 pi r over 2, we could rewrite that as just pi r. Because if we're multiplying pi r by 2 and then dividing it by 2, we end up back where we started. So 12 pi, and then we just combine, we get 36.
48 pi r.
Not
This is probably a really bad.
36 plus 12 pi.
I think it's
How do I get 36? 6 plus 6 is 12, plus 24 is 36.
Yeah, plus it's 12.
No, these are different things. 12 pi, this 24 means 24 1-yard sticks, right? This 12 pi yards means 12 pi yardsticks. These ones are each about 10 feet long. These ones, 12 times pi. These are not like terms. When you have pi in there, they're not like terms. We can sort of think of pi like a variable in that sense. Notice there's no pi in these first 3 numbers, so we can't add them to this one that has pi in there, unless we convert the pi one so that it doesn't have pi in there anymore. All right, any last questions quickly?
Number
No,
27.
I don't want to go over another problem. Any conceptual problems?
Whenever I'm doing like half a circle,
Yes.
the circumference of half a circle,
Yes.
I always just do like the radius and then pi.
Yes. Yeah, you can just do pi r. Yes.
Okay.
Yeah, you don't have to like write this all out, as long as you remember that. But make sure that you're keeping straight half the circumference is pi r, and half the area, right? Half the area is going to be pi r squared over 2. This one you can't simplify. This one, for the area, you just have to do pi r squared and then divide it by 2. Last questions? Okay, let's talk about exponents. Exponents. This shouldn't be too new. I'm going to erase this stuff over here. Exponents. What do I mean when I talk about exponents?
The number above a number.
Above. What do you mean when you say above? Like the top number in a fraction?
No. Like there's gonna be a number and then like to the top right before.
Yes. Yeah, exponents will be written above and to the right, like this. 4, but then a little 2 up and to the right. 4 squared. X cubed. 1/3 to the 4th. Something like that. These are exponents, these little numbers up here. what does an exponent mean? Now, actually, let's get some terminology first. Which one of these things is the exponent?
2.
Yeah, in this one, the 2 is the exponent.
I think that's a 5.
This is a 3.
Oh,
No, that's this one.
and 4.
Yeah. The other part we call the base. This is the main. I think it like the main number.
Use the restroom.
Ugh. Once I figure out how to write today. Okay, go ahead. Main number. All right. We can also call the exponent a power. So we can say 4 to the power of 2, x to the power of 3, 1/3 to the power of 4. You should know these words. Base, power, exponent, or we can say 4 to the 2nd power, x to the 3rd power, 1/3 to the 4th. What does it mean when we use an exponent on something? What does that tell us to do? What does an exponent tell us to do?
Multiply the base times itself that many times.
Right, take that many copies of the base and multiply them together. So 4 squared, what are we going to do if there's 4 squared? How are we going to figure out what the value of that is?
16.
How'd you get 16?
4 times 4.
4 times 4, we take 2 4s, 4 and 4, and we multiply them together, we get 16. What about 1/3 fraction raised to a power?
Oh, 1 times, 1 over,
81.
How do we figure out the value of this?
81.
yeah, 81.
It's not 81.
1 over 81.
Okay, 1 over 81. How do you get 1 over 81?
No, that's what I said.
One
I said
times
one
four.
over, I said 81.
Oh,
1
sorry.
times 1 times 1 times 1, and 3 times 3 times 3.
Right, so we can think of it either we raise each of these numbers to the power 1 to the 4th is 1, 1 times 1 times 1 times 1, and then 3 to the 4th. Or we can think of it in a more basic sense as we're taking 1/3, we're taking 4 copies of that, because it's to the 4th, and we're multiplying them together. And when we multiply fractions, remember we just go across the top, 1 times 1 times 1 times 1 is 1, 3 times 3 is 9, times 3 is 2, the first 2 3's give you 9, the second 2 3's give you 9, 9 times 9 is 81. Then you don't have to multiply 27 by anything.
Is this our problem set for 19?
Yeah, 19 is going to be for tonight.
Wait, how many problems?
All of them, unfortunately.
What? Not so much. Why is that in a row? Wait, how many is it all of them?
There's only 7 problem sets that we're doing all of them throughout the year. All right.
It's all 7 in a row.
Now what about, no, it's not all 7 in a row. Now what about x to the 3rd? We've got a variable here, x to the 3rd. How do we figure out the value of this?
You gotta figure out the value of x.
Yeah, we need to know the value of x. We could think of this as x times x times x. Right? That's what x to the 3rd means. It means 3 copies of x multiplied together. But in order to go any further than that, we're going to need to know the value of x. But keep in mind that you can raise variables to a power also. X cubed, or x to the 3rd, means x times x times x. And then if they tell us a value for x, we can then figure it out. All right. Next up, what if we've got a negative number? So what if we have, let's say negative 7 squared. Actually, let's do 2 things here, because Saxon loves tripping you up with these. Negative 7 squared. What happens when we square negative 7? What are we doing?
Multiplying it by
Negative
7.
It's negative 7 times negative 7. So what do we get? We get positive 49, notice. Even though we started with a negative number, when we square it, it becomes positive, because we're taking 2 negatives and multiplying them together. Actually, before we do that, let's do a different one. What about negative 3 cubed? Negative 3 cubed. Negative what? Negative 27. Wait. Why is it negative? Right. If it's Q power, whether your answer is positive or negative is going to depend on the power. If it's an odd power, like 1 or 3 or 5 or 7, it'll end up negative because you have an odd number of negative numbers that you're multiplying together. If it's even, like 2, 4, 6, 8, 10, then your whole answer will be positive because you have an even number of negative numbers being multiplied together and they'll cancel each other out. Yes, everyone following so far?
Yes, Captain.
Okay, let me give one other thing that Saxon loves to give you. These are not the same. So notice we had negative 7 squared is 49. What about this? Negative 7 squared. That's the same, right? Isn't it?
Wait. No.
No, this is not the same. Why is this not the same? Well, just looking at it, what's the difference between writing this and this? This one has parentheses. And the parentheses here actually do make a difference. Why? In our order of operations, what do we do first?
Exponent. Wait,
Parentheses. Then we do exponents. Then we do multiplication. Remember the negative sign, we can think of that as times negative 1. It's a kind of multiplication. So if we have this, negative 7 squared, what do we do first? Do we do the exponent first, or do we do the multiplying by negative 1 first? The exponent comes first. So what's 7 times 7? Is 49, and then we make it negative. We do the exponent first. First we square 7, we get 49, and then we make it negative. Whereas with this guy, when the negative sign is inside the parentheses, that means that's part of what's getting squared also. That here with this one, what we're squaring is not 7, but negative 7. Negative 7 times negative 7, and we'll end up with 49. So be careful. You gotta look for parentheses when there's a negative sign on your number that's being raised to a power. If there's no parentheses, the power will come before the negative sign. You have to do that first. If there are parentheses, then you'll apply the power to the negative number. What's
not squaring something.
well, not squaring isn't going to do anything. What if we want to undo squaring or raising a number to a power?
Dividing it by that.
Not quite dividing. Remember, the exponent here, the same way that multiplication is repeated addition, a power is sort of like repeated multiplication. So we can't use division to undo. We're going to have to do repeated division or a square root. So imagine we have 16, for example. This symbol means the square root of. It means what number multiplied by itself will give me 16? 4. What about 25? 5. Okay, you should know the square roots up to about 12 or so, because that's part of your times table. Right? The square root of 144 is 12, because 12 times 12 is 144. All right. What about something like this? What about 27? The cube root of 27. So now, when we add a little number there, it means not 2 copies of the thing that we multiply together, but 3. So what number, if we multiply 3 copies of it together,
9.
9 times 9 times 9
Wait a minute.
is
Sorry,
not
I was not.
27.
I did it.
It's 3. 3 times 3 is 9, times another 3 is 27.
I did it dumb.
All right, what about the fourth root of 16? Is 2. Because 16 is 2 times 2 times 2 times 2. We can multiply 4 2's together and get 16. Okay, the other thing to realize here about these. What's 4 squared? What's 4 squared? 16. What about this? What about negative 4 squared?
16.
Is also 16.
Oh, because you're multiplying.
Because we're multiplying 2 negatives together. So technically, when we have the square root of a number, there are actually 2 possibilities. Same thing with this fourth root. Because -2 times -2 times -2 times -2, 4 -2's multiplied together will give us positive 16 also. So for roots, square roots, fourth roots, sixth roots, anytime it's an even number, there's more than one. Whereas what about the cube root? Is -3 a cube root of 27?
No, because then it would have to be.
Right. -3 is the cube root of -27. Because as we saw, -3 times -3 times -3, -3 cubed, will give us -27. When we're talking about cube roots, or fifth roots, if it's an odd number, there will only be one possible root, either positive or negative, the same as the original number. So the cube root of 125, for example, is 5. The cube root of a negative 125 is -5. Here's something that we can't do. Here's something that we can't do. Notice how -7 squared gives us what?
-7 squared.
-7 squared gives us 49. What about 7 squared?
7 squared gives us 49.
Gives us 49. So what is the square root of -49?
It is.
What number can we multiply by itself to get -49?
It will equal 2.
What's the problem with taking the square root of a negative number?
-2 to the power of 7.
What number is the square root of -49? The problem is when we take the square root, we're looking for a number that we can multiply by itself and get that number. What number can we multiply by itself and get a negative? We can't do that. Why? Because what happens if we try something positive? What's a positive times a positive? A positive. What if we try something negative? What's a negative times a negative? Also positive. In this class, and for quite a while in your math careers,
You said something before about what you should do in this house.
I'm not going to ask you to take the square roots of negative numbers. Cube roots of negative numbers, yes, we can do that. But square roots of negative numbers, fourth roots, sixth roots of negative numbers, we can't do that in this class because to do them requires something that you guys don't need to know, which is imaginary numbers. 7i is the answer to that. Where we say that I is the square root of -1. That's in the I stands for imaginary. These are imaginary numbers. They're not real numbers. We're not dealing with them in this class. Instead of this class, we're only going to deal with real numbers, not imaginary ones. So you can't take, for this class, for purposes of this class, you can't take the square root of a negative number. All right? Imaginary numbers are wonderful, beautiful things, but we're not going to deal with them here. All right? Yes? Questions about powers and exponents?
No.
So you should know that you can take, when you've got a cube, fifth, seventh root, whatever, you can take that many things of it. All right. That's about it for today. So it's going to be 19 all tonight. I'll get you the sheets. If you guys want to work outside for the last 10 minutes, you can do that.
Outside?
Yeah.
Like, go outside.
Yeah, if you want to go do your work outside.